Hello, everyone. A very good morning, afternoon, or evening, depending on where you are joining us from. Welcome to our webinar. I'm very thrilled to see such a great turnout today as we discuss our 5G core technology and the future of 5G technology and all the potential. I'm Deboshri Sarkar, the head of marketing here at Titanium Platform, and I'm honored to be your host for today's session. For those of you who may not know me yet, I have been leading our marketing efforts and spearheading marketing initiatives to bring innovative solutions to our customers. Today, I am particularly excited to be sharing this virtual stage with my esteemed colleague, Patrick Rokaita. He is the Chief Technology Officer at Titanium Platform. With his wealth of knowledge and expertise in technology, Patrick has been instrumental in shaping the direction of our 5G initiatives and ensuring that our solutions remain at the forefront of the industry innovation. Welcome, Patrick. So, together, Patrick and I will be guiding you through an insightful exploration of our next gen 5G core solutions, shedding light on the advancements we have made and the opportunities that lie ahead. So before we dive into our agenda, let's go over a few housekeeping items. So all attendees today are on a listen only mode. So if you have any questions during the webinar, please feel free to type them in the Q&A chat box. We will address them during the Q&A session at the end as per the time permits. If we are unable to answer any of your questions, our team will reach out to you. Also, please feel free to reach out to us. We highly encourage that. Also, this webinar will be recorded and will be made available for viewing afterwards for those who couldn't attend live. So sit back, relax, and now let's dive into today's agenda. So throughout the session, we will provide insights into each of these areas listed here and discussing their importance, applications, and the impact. I will be briefly going over our 5G core solutions, and Patrick will give us a very deep insight into a few of our solutions, the real world use cases, the implementation, and the best practices. Again, like I mentioned previously, at the end, we will go over your questions. So, with that, let's go ahead. Um, so I would like to take a moment to introduce our company, Titanium Platform. For those of you who may not know us, Titanium Platform, we pride ourselves on being an industry leaders in signaling, routing, subscriber data management, and security software and services. Our solution um, is trusted and deployed in more than 80 countries by over 180 companies, including 8 of the world's top 10 communication service provider and all of the top 5. What sets us apart is our ability to support any network, domain signaling protocol, and infrastructure with advanced routing capabilities, ensuring a very unified user experience. So whether it's 5G, LTE, or legacy networks, our platform is designed to adapt and excel in any of these environments. Um, so we thought it would be interesting to explore the timeline of evolution of the 5G core technology, and this is an overview that will provide a very valuable context for understanding our Titanium's 5G journey, which we will discuss in the following slides during our webinar today. So what you can see is that in 2019, the foundation was laid with the standardization of the 5G core specifications, setting that stage for what had to come next, right? So what we all have seen that by 2020, we witnessed a very pivotal moment with the introduction of the 5G standalone architecture, which basically unlocked the new levels of independence and the potential for 5G networks. And fast forward to 2021, we saw the commercial deployments of standalone 5G networks, marking that significant leap forward in accessibility and adoption. And then as we entered 2022, the landscape really expanded with many use cases and applications actually showcasing the versatility and the impact of the 5G technology across various industries. Again, then now, like in 2024, what we have seen is that we are at this forefront of 5G advance, and with release 18 pushing that boundaries even further, it has propelled us into really new era of possibilities with the 5G technology and more. So very interesting. I thought it would be great to share, the evolution journey. And now that we have looked at the journey, let's shift our focus to some of these driving forces behind the adoption of 5G network solutions. I wanted to particularly highlight the need for increased bandwidth, right? This also addresses the growing demands for a very enhanced mobile broadband and innovative technologies such as fixed wireless access. So we have worked with our customers, and over the years, we have really seen that these have been some of the drivers for 5G technology. And also wanted to highlight the competitive pressures that drives organization to embrace the transformative potential of these 5G technology. So yeah, so I mean these factors really collectively shape the landscape for the 5G adoption. Moving on, let's dive into the areas which are the prime focus of our webinar today, which is our Titanium's 5G core solutions. So here is an overview of Titanium's 5G core solutions. These include the Security Edge Protection Proxy, also known as SEPP, the Service Communication Proxy, the Network Repository Function, Binding Support Function, Network Slice Selection Function. So we'll explore each of these essential solutions that we provide in our slides today. I will be just briefly going over each of these 5G solution, and Patrick will provide us very deeper insight each of these. So the first one we are exploring here are the core benefits of our SEPP solution, which is the Security Edge Protection Proxy. So in 5G networks, we know that that's kind of the future of telecommunication, but we all know they come with their own set of security challenges, and that's where SEPP actually comes in. The 5G Security Edge Protection Proxy solution, which provides a very robust protection against these threats and vulnerability. It ensures that the data is secure and the connection is seamless. With SEP, you can really roam between different networks and geographic locations without really worrying about being interrupted in connectivity. It also strengthens that interconnect security, ensuring the secure exchange of data between the operators and the external networks. And the best part, SEP is scalable and flexible, so it can meet the evolving needs of the 5G networks. So let's look at our next 5G core solution, which is our service communication proxy. Um, Firstly, the service communication proxy acts as this centralized control point in the signaling network core, similar to a diameter routing agent in 4G. This centralized control basically facilitates very efficient message routing, load balancing, and distribution across the network. Also, Titanium SEP solution enhances scalability by simplifying the core network routing topology and offloading the network repository function from service discovery. And this enables, greater scalability, ensuring that the network can accommodate the increasing demands without really compromising that performance, which is so important. Also, SEP solution includes that robust traffic management capabilities. It prioritizes traffic, handles that overload situations efficiently, and ensures a smooth traffic flow across the network again, emphasizing that it optimizes the performance and reliability. So, what we can say finally is that the SEP really facilitates that 5G service delegated discovery, allowing the operators to easily discover and access the critical network functions. And this capability streamlines the network, yeah, the network management and the deployment process, which basically at the end enhances that operational efficiency and agility. So really very important component in our 5G set of 5G core solutions. The next one is our network repository function. Again, it serves as a very centralized services discovery broker, which dynamically helps with registering and retrieving information about all the deployed network elements. This is not only not only like streamlines the network operations, but also lays the foundation for scalability and flexibility in the network architecture. And with support for layered development and inter-public LAN mobile network interconnectivity, our NRF ensures that there is a seamless service discovery even in mobile 5G roaming scenarios. Furthermore, acting as a central OAuth 2.0 authorization server, it helps fortify the network security by regulating access to the NF producer services, which is delivered, and also it's delivered on our cloud native framework. So the NRF embodies really the efficiency, scalability, and the robust security, making it one of the cornerstone of the next gen 5G network. So moving ahead, let's dive into our binding support function. It plays a very pivotal role in enhancing the data session management within the 5G networks. Firstly, what it does is it optimizes the resource allocation by efficiently directing the applications to the policy control function, holding relevant session information, reducing that latency, and improving that overall network performance. Secondly, it seamlessly integrates with your network infrastructure, minimizing that disruption to the operations. Also, BSF offers that scalability and flexibility, adapting to the growing network demands and your evolving business needs. Lastly, by facilitating a very quick and accurate data session discovery, what BSF does is it enhances the overall network efficiency, which results in improved operational efficiency, of course, and also leads to cost savings. So in summary, we can say that BSF really ensures that efficient data management, helps with that seamless integration, scalability, and enhanced network efficiency within 5G networks. Also making it one of the key components within Titanium's comprehensive suite of 5G solution. So next up is our network slice selection function, which it offers really compelling value for the network, the operators seeking to unlock that full potential of their 5G networks. So with network slice selection function, operators gain the enhanced network flexibility. They are able to create those customized network slices tailored to specific industry needs. This really allows for the optimal resource allocation, ensuring that superior performance and reliability across diverse applications. So another very important 5G core solutions that we have, and combined in combination, like what are those business challenges that are addressed by the Titanium suite of 5G core solutions? Is that let's explore those. So first up, we have the Security Edge Protection Proxy, which is a SEPP. It ensures that secure 5G roaming signaling, which is vital for maintaining the network integrity, is maintained. Next, the Service Communication Proxy steps in to enhance the network efficiency by centralizing the routing and network function discovery, reducing that unnecessary signaling traffic. A very important component again. Our network repository function plays a very pivotal role in dynamically exposing the service information, enabling seamless communication among the 5G network functions. And meanwhile, the binding support function allows application to efficiently discover that critical data session information, enhancing the overall network efficiency. And finally, we can say that the network slicing support function drives the performance by enabling the allocation of dedicated core resources to the vertical industries, ensuring that the optimal service is delivered. So together, these solutions tackle the security, efficiency, and the performance challenges uh, addressed. Um, experienced by the businesses. So having gained the insight into the comprehensive range of the 5G core solutions that are offered by Titanium platform, let's now shift our focus to understand the company's journey and the pivotal contributions in shaping the landscape of the 5G technology. So we have represented that through a timeline of the key innovations and milestones here. We will, explore like how Titanium has really continually evolved to address the ever-changing demands of the telecommunication industry. So let's take a look. So in our timeline of Titanium's 5G evolution, we began in 2018 by adapting our Titan 4G products for the 5G NSA, laying that groundwork for the future of innovations. The following year marked the start of our work on the next generation cloud native platform, setting the stage for scalability and flexibility. And you can see by 2020, we had implemented key 5G core functions and initiated the proof of concept activities. And in 2021, we proudly launched our next generation Titanium platform, which really propelled us forward in driving the industry leading advancements. Over the next 2 years, we expanded our platform services and achieved over 10, 10 successful POC deployments. And a very significant, this is something to note here, is that we milestone was really reached in 2023 with the production level deployment of our SEPP solution, which actually showcases our reliability and security. So as we look to the future, our commitment to innovation really remains, unwavering, and with the ongoing advancement and a focus on addressing the industry challenges are really head on for us. So now that we have gained a very comprehensive understanding of Titanium's 5G core solutions and the key value in driving the innovation and connectivity, I am pleased to pass this virtual floor to Patrick. So Patrick, over to you.
Thank you, Debashri. So hello and welcome to the second half of the Titanium 5G webinar. For those who may have missed the interaction. I'm Patrick Rokita, the Chief Technology Officer here at Titan.ium. And yeah, with a career spanning the technological evolution of mobile networks from the second to the fifth generation, it's a pleasure for me to elaborate on the role and importance of mainly two critical components of the 5G core, the Security Edge Protection Proxy and the Service Communication Proxy. At the end of my presentation, that will also touch on the implementation and integration aspects of 5G core network functions in general. I will showcase selected real-world use cases and also provide a brief outlook on the future of 5G technology. So let's start with a SEP. And very interesting message. In the 5G core service-based architecture, and for the first time ever, the 3GPP standards define a dedicated node to safeguard the perimeter of the mobile core from fraudulent network access and message content spoofing. And yeah, that's the Security Edge Protection Proxy. And there was some leveraging of the experience with a 4G diameter edge agent defined by the GSMA. And by doing that, the steadfast commitment of the SEP to security fosters trust and confidence in the use of 5G standalone services when roaming outside of the home network. And yeah, think, for example, of driving a car connected to a 5G network slice and then crossing the country border. This is exactly the point at which 5G standalone roaming comes into play. At the heart of its function, SEP facilitates secure connections between various P elements, ensuring seamless communication while upholding stringent security protocols. The SEP either facilitates direct connections between the home network and the visited networks, or it orchestrates these connections through trusted IPX providers or IP interconnect hubs, leveraging their infrastructure to extend the network reach without compromising security, of course. The SEP offers a spectrum of deployment models tailored to meet diverse operational needs. Managed internally by the mobile network operator, the local SEP or the MNO SEP deployment empowers the operator with granular control over security measures, aligning seamlessly with the operational frameworks and policies of the MNO. The drawback of this model arises from the increasing number of roaming partners and the operational complexity involved in managing and securing each of the interconnects individually. So alternatively, the MNO can opt for outsourced or hosted SEP solutions managed by a trusted IPX provider. This model not only offloads operational burdens, but also ensures and adherence to the industry best practices under the stewardship of professionals who are experienced in global roaming and interconnect. And it is especially the hosted SEP solution that can effectively help mobile network operators manage the trade-offs between security, operations, and business concerns. The Titan.ium Security Edge Protection Proxy operates on a zero trust paradigm, implementing a bilateral trust model where every interaction is scrutinized. This means that every message routed through the SEP undergoes strict validation of both the source and destination P element, and moreover, all roaming and interconnect messages traversing through the SEP are encrypted using a robust IT protocol stack, shielding sensitive data from malicious actors. This slide visualizes the different SEP deployment models. You see MNO1 deploying local SEP and MNO2 with no SEP deployed. So with a local SEP, MNO1 has the possibility to directly connect with its roaming partners. You see it on the top of the slide. The trick is that mastering security on 5G interconnects requires in-house security knowledge, testing capabilities, and tool sets to identify and mitigate signaling threats. And also managing hundreds of 5G interconnect agreements may not be something the mobile network operators want to do themselves. Fortunately, because of the local SEP, MNO1 has also the option to connect its local SEP to the SEP hosted at a trusted IPX provider and then delegate the responsibility for managing and securing the PLMN interconnects to the IPX provider. And certainly, MNO1 can also combine both options. Now, when looking at MNO2, MNO2 is not deploying any SEP in its 5G core network and instead outsources the SEP to the trusted IPX provider, who again takes responsibility for managing and securing the PLMN interconnects with the roaming partners. Worth mentioning, MNO2 can, at any time, introduce a local SEP in its 5G core network and hook it up directly with its roaming partners or with the SEP hosted at the trusted IPX providers of the MNO's choice. So that's highlighting the importance of the trusted IPX provider serving as the first hop for the MNOs, so that the MNOs can do the job they are good at, and the IPX provider then secures the interconnect and the roaming traffic that goes over the IP interconnect network. All three SEP instances, the local SEP, the hosted SEP, and the outsourced SEP, are associated with a dedicated PLMN identity. Yeah, so obviously the local SEP and the hosted SEP are associated with the MNO1's identity, and the outsourced SEP is associated with the MNO's 2 PLMN identity. The fourth instance of the SEP that you see in the middle, representing a roaming hub, exposes a generic identity that is not related to any particular PLMN. The roaming hub serves as a roaming intermediary, extending the reach of the IP interconnect network, and can be utilized equally by MNOs and IPX providers. Ensuring the security in roaming scenarios is vital, as 5G users engage in the use of 5G standalone services with confidence. The Security Edge Protection Proxy sets a new standard for protecting our interconnected world. Because unlike its predecessors, 5G roaming adopts a bilateral trust model facilitated by the simple exchange of the root CA certificates. And this model, characterized by low operational complexity, ensures that trust is established and maintained individually between the interconnected entities, laying a robust foundation for secure communications. And furthermore, every handshake in the transport layer security protocol is not just formality, but a validation of a potentially fraudulent certificate chain against the explicit bilateral trust agreement. So compared to legacy networks that we know from the past, there are real advancements leveraging the security in 5G SA roaming scenarios. And there is more. So prior to any message routing, the SEP engages in a secure negotiation of security capabilities. And this proactive approach ensures that only authorized entities with verified security and routing capabilities are granted access to the network, obviously minimizing the risk of an unauthorized access. The security is further enhanced by segregating connections exclusively for security capability exchange and message routing. During message routing, strict validation protocols are enforced on every routed message. The source and destination PLMN IDs are verified to prevent spoofing or unauthorized access attempts. And in addition, the intended usage of connections between the PLMNs is continuously validated, ensuring that network resources are utilized within the contracted scope. As already mentioned, all internal and external 5G core traffic is encrypted using the transport layer security protocol. And then there is PRINCE, the protocol for N32 interconnect security. PRINCE ensures end-to-end integrity protection of the routed message content while enabling value-added services derived from data routed across the globally interconnected 5G core networks. Unfortunately, the complexity that comes with the functional and operational requirements, and especially with maintaining the associated service level agreements, and we are talking about several hundreds of such agreements, makes Prince lag wider industry acceptance. And therefore, the telecom community is currently relying on so-called hop-by-hop transport layer security via trusted IPX providers, while discussing an alternative approach for maintaining end-to-end security, especially when routing messages through untrusted intermediaries. So this was a brief overview of the role and importance of the 5G Security Edge Protection Proxy. And now let's move to the Service Communication Proxy. The Service Communication Proxy was introduced in 3GPP Release 16, positioning the SCP as a central hub component through which all 5G core signaling traffic is routed. And with this, the SCP eliminates the need for separate implementation of signaling, routing, security, and other capabilities across multiple 5G core products from different suppliers. All these capabilities are basically centralized on the SCP. So similar to the signal transfer point, SDP, in 2G, 3G networks, and the diameter routing agent in 4G networks, the SCP facilitates indirect communication between the network functions in the 5G core. And by communicating with the network repository function, the NRF, the SCP implements the discovery and selection of suitable service producers, ensuring efficient routing and rerouting of service requests. In addition, as already mentioned, the SCP orchestrates the request and delivery of service access tokens, centralizing and streamlining the entire service access security process. And moreover, implementing caching capability into the SCP reduces traffic to the NRF, enhancing overall efficiency. And there is more. The SCP can extend its reach beyond the local 5G core network, serving as a gateway for routing to other SCPs deployed in disparate domains or locations. And this flexible interconnectivity, which also includes the PLMN interconnect traffic via the Security Edge Protection Proxy, fosters a simple configuration of the adjacent nodes. At the same time, the SCP effectively conceals the 5G core network topology, such as IP addresses. In addition to its service discovery and service request routing capabilities, the SCP emerges as a central point for a variety of services, including centralized traffic monitoring, mirroring, and load control. And through real-time insights delivered, for example, by network data analytics, the SCP orchestrates load balancing, mitigating overload scenarios, and so ensuring seamless user experiences. Notably, the unique power of the Titan.ium SCP lies in its message screening and content enhancement capability. By intelligently filtering and enhancing message content, the Titan.ium SCP enhances security, improves interoperability, increases fault tolerance, and elevates the overall quality of service delivery. But let's explore the architecture of the 5G core networks as we move to the next slide. So to make the role of the SEPP and SCP more obvious, I've created two diagrams showing a 5G core network without the service communication proxy on the left and a 5G core network with the service communication proxy on the right. Both networks are directly connected through the Security Edge Protection Proxies. So as you can see, without the SCP, all network functions in the 5G core are interconnected. Also, the SEPP must maintain these dedicated connections to each network function, which may introduce complexity if you outsource the SEPP to a trusted IPX provider. Using SCP, each network function in the 5G core has connection only with the SCP, including the SEPP, and this we call the star topology. The utilization of a star topology or hub and spoke topology is a familiar concept in the telco networks where, as already mentioned, centralized components such as the signal transfer point in 2G, 3G networks and the diameter routing agents in 4G LTE networks have historically played a crucial role in routing. And therefore, the introduction of the SCP as a centralized component for signaling and routing in the 5G core naturally represents a logical architectural progression. It's important to acknowledge that centralized routing in legacy networks was necessitated partly by the use of the Stream Control Transmission Protocol, SEPP, which demanded a highly granular, means endpoint level configuration of the network components. However, with the advent of HTTP2 in 5G core networks, this complexity diminishes significantly. The HTTP2 protocol inherently supports full mesh services topologies through the combination of the domain name system, DNS, TCP/TLS transport protocol, and network address translation, providing for virtually unlimited web-scale networking, widely adopted by the IT industry. Yet, despite this shift, the prospect of routing all mobile call traffic through a centralized component like the 5G SCP remains highly appealing due to the benefits we have discussed. With this, we have wrapped up our discussion on enhancing network scalability and efficiency with a service communication proxy. And let's now pivot our attention to the implementation and integration of the 5G core network functions. The implementation of 5G core network functions demands a holistic approach that extends beyond traditional software engineering. The fifth generation of the mobile core networks has ushered the telco industry in the era of cloud-native technology, introducing highly scalable container-based microservices architectures and the associated processes. And with a cloud-native technology, mobile network operators can build robust, agile, and scalable 5G networks that are definitely future-ready and primed to revolutionize the global connectivity and user experience by offering attractive and monetizable services. So let's elaborate on a few key aspects of implementing 5G core network functions. Definitely ensuring compliance with standards and recommendations set by 3GPP and GSMA is foundational, as it lays the groundwork for interoperability and integration. But the journey doesn't stop there. The transformation of the software development processes from the traditional waterfall approach to agile models like continuous integration and test is inevitable to successfully cope with the increased number of components resulting from the decomposition of monolithic systems into smaller single concern modules that we also known as microservices, developed in-house or integrated from leading open source community projects. And compared to monolithic systems, microservices enable rapid development, deployment, and scaling of network functions. Simultaneously, conducting thorough software composition analysis and vulnerability scans is essential to safeguard against potential security breaches and ensure, for example, the integrity of licensing across imported software modules. This process is referred to as the secure software development lifecycle and is implemented for all Titan.ium products. At Titan.ium, we in addition leverage a central cloud-native platform that is streamlined for the delivery of services essential for operations that are common to all 5G core network functions, such as data storage, data replication, identity management, telemetry OEM, service mesh, certificate lifecycle management, and more. So utilizing Titan.ium's cloud-native platform for the delivery of common services strengthens the single concern paradigm, which is fundamental when building highly scalable and reliable system based on microservices. Each iteration in the implementation process may trigger the release and delivery of the software to the customers. And the delivery process, again, triggers the deployment process that propagates the released bug fixes and enhancements across the customer's network. And to seamlessly integrate with the customer's 5G core network as a dynamic and adaptable entity, modern frameworks and methodologies are combined to achieve convergence. Leveraging OCI compliant container images and Helm for the creation and packaging of the descriptor files, the 5G core network functions can be deployed and ported across any Kubernetes cluster. Kubernetes is the container orchestration framework that is widely used in the deployment of cloud native solutions. Then embracing REST-based interfaces that adhere to open API standards that enables not only integration with the operations and business support systems, but also provides for the exposure of the network to external developer communities for the creation of additional 5G services, enabling the network to swiftly adapt to evolving demands. To optimize performance and resource utilization, the container orchestration framework, Kubernetes, facilitates horizontal autoscaling, dynamically adjusting the number of replicas of all network function components to match fluctuating traffic. Anomalies in the resource usage or in the ability to deliver the expected service are immediately detected and remediated by an automatic restart of the problematic component, or simply by excluding it from the service delivery. Canary rollouts further enhance the resilience of each microservice, enabling controlled deployment of bug fixes or enhancements only to a small portion of traffic, and so mitigating the risk of severe service degradation or service outages caused by unexpected software behavior. Central to the integration strategy is the support of GitOps, providing for a consistent and fully automated deployment lifecycle process utilizing Git as the single source of truth and continuous deployment frameworks for the automatic rollout and rollback of new software releases across the lab, pre-production, and production networks. And the utilization of GitOps is seen as one of the key aspects in the transition from telco to techco. And integral to security is the implementation of network policies, embracing the idea of zero trust architectures. Through granular permissions, each network function hardens its defense against potential threats initiated even from within the 5G core network. And last but not least, the use of transport layer security on every single connection inside the 5G core necessitates the automation of the certificate lifecycle management process that includes the integration with the operator's intermediate or root certificate authority. Yeah, with that, we shift our focus away from implementation and integration and explore some real-world use cases. With over 20 years experience in the implementation and delivery of signaling, routing, subscriber data management, and security products and services to the telco industry, Titan.ium's product portfolio encompasses network elements for centralized routing and the protection of the perimeter of the mobile core networks, spanning from 2G, 3G to 4G, and now also 5G. Titan.ium cloud native platform and application featuring the Security Edge Protection Proxy and the Service Communication Proxy alongside additional 5G core network functions, we heard that, and also selected legacy products underwent successful testing across various proof of concept activities, where some of these trials remain ongoing or have just started, while others have already transitioned into live deployments within production systems. But most importantly, all these activities have leveraged the strengths of the Titan.ium products, not only from the functional perspective, demonstrating a high degree of standard compliance and interoperability, but also in terms of the implementation of processes defined for the delivery and deployment and operations of cloud-native microservices-based applications. And in the end, it's my personal opinion, it appears that the processes and the level of automation are what hold particular interest for mobile network operators who have already transitioned their infrastructure and workforce to cloud native, because they enable them to build and operate secure and scalable 5G networks in an economically efficient way. So let's elaborate on a few experiences collected during these activities. The first experience, 5G standalone roaming and interconnect, involves deploying outsourced and hosted SEPP instances at an IPX provider. These instances serve as the first hop for mobile network operators. We heard that, transferring the responsibility for managing and securing roaming and PLMN interconnects to the IPX provider. The uniqueness of this deployment lies in the strict utilization of Git as the single source of truth from which all deployment artifacts are sourced. With that, the deployment process is fully autonomous and automatically re-triggered upon the upload of new artifacts to the Git repository, referred to as the continuous deployment process. And mastering this continuous deployment process around Git is a key aspect in the evolving world of automation and autonomy. So very important to master that in parallel to manual processes that utilize, for example, CLI-based Helm commands. The second experience, the multi-tenant roaming hub, is quite similar to the previous one, with a difference of hosting multiple mobile network operators on a single instance of the hosted SEPP. This deployment flavor is a pretty viable alternative for early adopters targeting the deployment of a roaming or service hub that is still being worked on by the GSMA community. A particular challenge that had to be addressed and solved in this deployment model is the support of multiple SEPP identities along with the correct utilization of the associated certificate chains. And so instead of hosting one identity on the instance of the hosted SEPP, you host multiple identity and need to really sort out the certificates chains across the relevant connections. The next experience, the interoperability hub, is something we encounter in almost every proof of concept activity and even in some production level deployments. In a nutshell, there is always an interoperability problem or routing scenarios that requires an unforeseen tweak to the deployed solution. Where the Titanium products are historically known and valued for their native implementation of comprehensive message content screening and modification capabilities across a multitude of industry protocols. And the 5G related examples include, for example, adding missing headers required for successful service discovery, or adding 3GPP release 17 headers to messages originating from pre-release 17 consumer network functions, or adding customer-defined rules for advanced selection and reselection of producer network functions. All the listed scenarios utilize the capability built into the Titanium SEPP and SCP, as well as into all other Titanium 5G core network functions to screen, add, modify, or remove any parameter in the HTTP2 message, including both headers and payload. The fourth experience to share, traffic mirroring, successfully mitigates the gap in capturing content of the signaling messages by tapping the messages directly on the wire. In 5G core networks where all internal traffic and all external traffic is encrypted, this approach naturally fails and alternative solutions must be implemented. So Titanium 5G core network functions implement traffic mirroring by sending a re-encrypted copy of the received messages to the network data analytic platforms of the customer's choice. This functionality can be further evolved once the suppliers of the network data analytic solutions implement the vendor-neutral API defined by the Open Tracing Community Project. With that, we have elaborated on selected real-world scenarios utilizing the unique capabilities of the Titanium 5G core network functions. And there is one final thought to share. What is the future of 5G technology? The future of 5G technology is, obviously not a destination, but a journey. And while the discussion about 6G has already started, there are still at least 5 years of mobile network evolution ahead of us that will utilize 5G. And this phase is referred to as 5G Advanced or 5G Plus. The beacon guiding the journey of communication service provider is the delivery of attractive and monetizable services to users, enterprises, and verticals. And at the heart of this evolution lies the constant demand for more data, more speed, more connectivity. And this will not change, especially in the user market segment. And at the same time, the deployment and operation of services utilizing 5G and cloud-native technology must be continuously optimized for economical reasons. For example, through a higher level of automation and autonomy, ultimately leading to a zero-touch operational experience where networks run securely and with efficiency without human intervention. Yet efficiency in terms of automation and autonomy is not the sole pursuit. Energy efficiency becomes a mandate where 5G networks must minimize their environmental footprint while maximizing their impact in new market segments such as extended reality, artificial intelligence, quantum computing, and non-terrestrial networks. Extended reality and the use of artificial intelligence, for example, in the real-time optimization of the radio network resources, will move the network closer to the user and the applications closer to the network edge, with the edge computing technology introducing a new era of low latency communications. Speaking of applications, the once guarded fortress of network assets is now opening to external developer teams. I already mentioned that, turning the 5G network into a collaborative ecosystem exposed via standard APIs that are out there to democratize and breed innovation. And in the future, I'm sure we will see more of these standard APIs. Then there is network slicing that evolves as a key technology for offering tailored subsystems with dedicated quality of service parameters to verticals, empowering industries to carve out their own path in the midst of digital transformation, or simply serving as a secure and isolated ground for training machine learning models, for example, with the help of digital twins. And it will be the integration of AI directly into the network functions, and with it the evolution of CNF to AINF that will pave the way for AI ML to not just augment but orchestrate every aspect of the network, from operations to security. And apropos security, as this presentation targets the 5G Security Edge Protection Proxy, one of the security aspects to shed light on will come from the ongoing discussions about the automatic discovery of the remote SEPP instances, and at some point also about securing global interconnects against attacks originating from quantum computers, ultimately leading to the implementation of symmetrical cryptography and post-quantum cryptography in general. And there are sure topics that are still beyond the horizon. For example, the use of Web 3.0 and blockchain as the cornerstone upon which the future of telecommunications could be built. We don't know it yet. Time will tell. We have reached the end of my presentation, focused on providing a clear understanding of the role and importance of the 5G Security Edge Protection Proxy and the Service Communication Proxy, outlining the key aspects associated with the implementation and integration of 5G core network functions in general, and showing how the future of 5G technology may look. And with this, I'm handing back over to Debashri for a final wrap-up and a Q&A session. Thank you.
Thank you so much, Patrick. Really, really great and valuable, deeper insights. I'm sure everyone has learned a lot, and thank you everyone for listening in. If you are here so far, so yes, and we have received really great questions, and I was able to actually go through all the questions that we have received so far. So yeah, let's quickly dive into our Q&A. Let's see. Let's look at the very first question. So you mentioned the use of HTTP to over TLS protocol as one of the security measures natively built into the 5G network functions. Don't you think that attacks against the HTTP protocol are more sophisticated compared to the ones targeting SS7 or diameter? Patrick, would you like to take this question?
Yes. Okay. Yeah. Great question. And yeah, so what I think, I think it's true. Definitely, the attacks against the HTTP protocol are more sophisticated compared to the ones that target SS7 or diameter. And I also believe that the um, size of the community that involves potential attackers is much larger in the HTTP area and DNS area. What are those are the protocol that we use when browsing internet, than the community around SS7 and diameter. But even the attacks are sophisticated and maybe more frequent. Um, they will hit the security measures that were implemented that are implemented since decades across the IT industry, and that also safeguard internet every single day from fraudulent network access or message content spoofing. It's a difference if you have more sophisticated attacks and hit all these security measures that successfully deflect these attacks, rather than when you have less frequent attacks and don't observe any security measures at all. Yeah, so SS7 network are mainly unprotected, and also the diameter networks are not secure enough, in my personal opinion. There is activity around bringing signatures into diameter messages to protect the integrity of the message content. But I personally didn't see any notable amount of implementation of encryption across SS7 and diameter protocols, which would mean the implementation of so-called DTLS across the multi-homed SCTP traffic. So yeah, while the assumption or the observation is correct, I believe that also the defense that is implemented across internet, the HTTP and DNS protocol is at a sufficiently high level and will be continuously improved as we enter the post-quantum era, where quantum computers become affordable to attackers and will increase a new quality of attacks to internet networks. I'm sure that at the time the 5G core network will be ready to deflect these attacks.
Great, perfect. So I see another interesting question, Patrick. Actually, I think this is again for you. So the question is, can you elaborate on one or two challenges and how to address them when integrating cloud native components like the 5G core network functions with the underlying cloud native platform?
Okay, so I assume the underlying cloud native platform refers to the cloud native infrastructure. So yeah, definitely, we don't have that we in compared to IT vendors that do development and deployment on the same cloud native platform. In the telco industry, there's a split of responsibilities between the suppliers and the communication service provider that also have their supplier for the cloud native platform. So definitely there is handover of deliverables, and therefore each party is doing its part in a definitely great team spirit to achieve a overall working solution. But there is definitely a split of responsibilities. Like the suppliers mainly concentrate on delivering these OCI compliant container images and Helm charts, while the cloud native infrastructure providers are delivering the cloud native infrastructure with container as a service components and some of the platform as a service components. And this line of responsibility, or the split of responsibility, must be clearly defined and understood. Uh, we see some gray areas where the parties are looking at each other, saying who will solve this particular issue, um, because it was not clear that problems may arise at that interface. So yeah, one or two challenges. So maybe a positive aspect. I'm pretty much surprised how the integration of cloud native storage is, how seamlessly it works across the deployments that I have observed. So bringing in the container storage interface drivers is pretty straightforward exercise, and there was never issue with that, no significant issue with that. What I believe is the most challenge is managing the ingress and egress of the traffic that goes in and out of the 5G core network in a web scale dimension. And the stack, the cloud native stack for web scale networking is pretty complex. Yeah, it involves the network interfaces. It involves additional drivers. It involves load balancing controllers. It involves ingress and certificate management. And there, the integration is, in my opinion, the most challenging across other aspects of deploying and running cloud native applications on a cloud native infrastructure. So it's definitely the ingress egress part of the cloud native stack that brings the most challenges to all parties involved in the deployment.
Yeah, thanks, Patrick. Let's see. We can quickly take this last one,
Mhm.
probably. Yeah. So, can you provide insights into Titanium's collaboration with industry partners or standard bodies to drive innovation and ensure interoperability in the 5G ecosystem? I can actually take this question, and Patrick, please do add if I have missed out something. So yeah, I think that from what I understand from this question, so I can say that we here at Titanium, we collaborate very closely with the industry partners and standard bodies such as the 3GPP, GSMA, and IEEE to drive that innovation and ensure the interoperability in the 5G ecosystem. And through our active, participation in the forums and the strategic partnerships with, some of the very leading technology companies, we have been able to contribute to the development of the 5G standards and then co-create these solutions that are aligned with the global standards that accelerate the adoption of the 5G technology, for us. So, yeah, I think that I hopefully answers the question. And Patrick, do you have anything that you think that I might have missed out here?
It's what you said is all correct. I would just add that we also engage in in the work with the open source community project, because more than 50% of our cloud native solution is integration of publicly available community projects that are leading in the cloud native landscape. And I know I'm bringing issues or feature requests back to the community, and being part of that community mainly on GitHub is important. And at the same time, as I mentioned, the exposure of the network assets and services via standard APIs to the external developer teams, it's also good to be around those community, whether it's GSME Camara or other communities that embrace the creation and spread of standard APIs for democratic and democratic innovation across larger communities than the suppliers teams itself. Yeah.
Yeah, absolutely. Yeah, thanks, Patrick. And yeah, I think we are at the top of the hour. And with that, we would really thank everyone for, we really want to express the sincere gratitude to everyone for, taking the time for joining us today, and also like your interest and enthusiasm to what, to events like these really make them so rewarding. And of course, our journey doesn't end here. We are committed to continuing the conversation ahead and exploring the further opportunities for collaboration and knowledge sharing. So if you have any additional questions or would like to learn more about our, 5G core solutions that we have covered today, please don't hesitate to reach out to us. And thank you everyone for your participation. Thanks, Patrick. And we look forward to our continuous engagement in the future. And with that, I would like to wish everyone a wonderful rest of your day. Thank you so much.